All right, lesson 5.2, medians of triangles. Okay, so first of all, what is a median? What is a median? So a median is nothing more than a line segment that goes to the middle. So if we look at it, middle of a side of a triangle. So if DK is a median, then K is the midpoint of EF. It's right in the middle. So I always tell students, think about median of a road. A median in a road is what's in the middle. So this gives us a couple of relationships here. First of all, for this particular picture, if DK is a median, then I know EK is equal to KF. So small equals small, so this kind of relates to our angle bisector. Small has to equal small. Another one would be EK is 1/2 of EF. So again, small is half of big EF. And then the last one is 2 times EK would equal EF. So again, going back to our angle bisectors, 2 times the small one would equal the big one. All right, now, having those set relationships using this particular example, we're now going to solve these problems. And one of the things you want to do is identify the relationship. So in this case, it gives me EF. All right, so EF, if I look at the segment EF, is the big. So I'm going to write the word big above this. It wants me to find KF. KF is the small. So going back to our relationship, small is equal to 1/2 the big. So in this case, KF, which is what I'm looking for, will be 1/2 of 10.1. So if I take half of 10.1, I get 5.05. All right, let's go to the next one. It says find X if UW, okay, UW, so UW is the big, and RW here is the small. So you could use this same relationship over here on the left, but I don't like fractions, so in this case what I'm going to use is 2 times the small equals the big. So 2 times the small one is 1 plus 1/2 x equals the big one, which is 2x minus 7. So I do my distributive property here, and I get 2 plus x equals 2x minus 7. Now I have to solve, so I subtract x, get 2 equals x minus 7, add 7 to both sides, and I get 9 equals x. So very, very similar to what we did with angle bisectors. So now that we've kind of seen this, I'm going to go ahead and finish these others here. All right, so let's take problem number 3. It says now find DQ, so I'm going to have to plug back in. So it gives me DQ, so I look, there's DQ. DQ is a small. And DP, okay, here's DP. DP is also small. So what do I know about the two smalls? I know they are equal. So here I have 2x minus 8, small has to equal x minus 2, small. Solve the equation. X minus 8 equals -2, add 8, and I get x is 6. Okay, now it says find DQ. So now what I'm going to do is take 6, go back in and plug it in here for what this expression was for DQ. So 2 times 6 minus 8. So that's 12 minus 8, which is 4. So DQ is 4. Now, a good way to check this, I should get 4 for DP. So if I take 6 up here, what's 6 minus 2? 4. So yes, that works. That shows that what I got for X, being 6, is correct, and my value for DQ is 4. All right. Let's go over here to do number 4. It says find QZ if ZC is 11. Okay, now this is a different relationship. This is one where two medians intersect. So I have two medians in this picture. I have RD and QC, two different medians. Well, there's a theorem that says if the two medians intersect, then they intersect at a point that is 2/3 away from the vertex. Okay, in other words, if Z to C is 11, then Q to Z is twice that. So that would be 22. Okay. Now that one's a little more difficult to read, but just remember, from the vertex to the point of intersection is twice as big as it is to the side of which it goes, which is 11. So 2 times 11 is 22. Hopefully as we do another example, that'll make a little bit more sense. Okay. All right, so here, again, we have two medians intersecting. And it tells me GS is x plus 3. So from G to S, from the vertex, is 2 times bigger than it is to the side. Okay, so x plus 3 is twice as big as S to Y. So S to Y would be half of G to S. So SY here would be, I'm going to write it out here, 1/2 of x plus 3, what it is from G to S. Now, why do I need that? Because the other thing they give me here is GY, which is from the vertex all the way to the side, the whole thing. So what I have to do is I have to take the two smalls, small plus small equals big. Small plus small has to equal big. So x plus 3 plus 1/2 times x plus 3 has to equal the big, which is 2x plus 2. All right, so do my distributive. This gets a little ugly here because I have fractions, but we can use the calculator. So add my like terms, so that's going to give me 1.5x or 3/2x, however you want to think of it. 3 plus 3/2 would be 4.5, which would be 9/2 equals 2x plus 2. Subtract 3/2 x. Again, use your calculator here to help you work these out. Slide it up a little bit so I got some room. So then those cancel, so I got 9/2 equals, that's going to give me 1/2 x plus 2. Subtract 2. If I do that, that's going to give me 5/2 equals 1/2 x. Then you can divide by half on the calculator, or I teach it as multiplying by the reciprocal, so that those cancel. So I'll multiply this by 2/1, so the 2's cancel here. And then that's going to give me 5 equals x. All right, one more here. So again, we have two of these intersecting. It gives me R to S. Okay, so that's from the vertex. So that's the bigger one of the two. -2 plus x. And then it gives me SZ, which is x minus 5. Now remember, this one is twice as big. Sorry about that. This one is twice as big as this one. So I'm going to write it as -2 plus x is twice as big, or 2 times as big as it is x minus 5. So remember, the one from the vertex right here is always 2 times bigger than the one to the side. So now I'm just going to work that equation out, do my distributive property. -2 plus x equals 2x minus 10. Subtract x. -2 equals x minus 10. And 10. And that gives me 8. Now, that is x, but it says find SZ, so I've got to take this, plug it back in. So I do 8 minus 5 is 3. So that is what SZ is. So that's my answer. Now, one thing I'm going to do is I'm going to take it and plug it into the other one as well. So I've got -2 plus 8, and that would be 6. Remember, this one right here from the vertex, from R to S, should be how much? Twice as big as this one. Well, 6 is twice as big as 3, so that proves that my value for X was correct. So a lot of stuff here. Hopefully, as we go over it in class, you'll gain a better understanding, and hopefully there's not a lot of confusion.